Now, mental math and addition and subtraction actually is a very powerful skill that students should absolutely have. We cannot expect that anytime there needs to be addition happening or subtraction, that a student needs to go and pull out a piece of paper and a pencil and line things up in a column and, write the add ends up and, carry and borrow or do whatever it is that we teach them to do. This is, we might as well just have them get a calculator and calculate this, or say, hey Siri, what is, whatever the addition problem is. So we really need to create for students a very flexible ability to work with numbers and to have a sense of operations, to have a sense of the properties of operations so that they can make the numbers easier. Now, there are a number of ways that this can be done, and we'll talk at length about some of the other ways. But here's one basic example where we get to use the commutative and associative property. Now, commutative is that order doesn't matter, and associative means the grouping is possible. So you can group of 3 or 4 or 5 different numbers. When you're adding them, you can group them in any way you'd like. And for commutative, it means that you can do that in any order. So for example, if we have 7,999 plus 857 plus 1, really this could be done in a nice long 7999, 857 and 1, and then we can regroup and do all of that stuff. Carry the 1. We'll talk a lot more about the language of our standard algorithms later on. Or we can have a student say, hey, this 7,999 is 1 away from a really nice number. And we actually are adding 1 at some point. So what we can do is we could say that that's 8,000 and plus another 857. 8,857. That's mental math. That is being flexible with numbers. That is working using the commutative property where we grouped the 7,999 and 1 first to give us 8,000. And, the commutative property where we moved the 1 over to the 7,999, and the associative property where we grouped those two and added those two first. That's really what we want students to understand and feel flexible with doing. So for second question, we know that 8 and 2 make 10, so we can group these. We don't need the commutative property. We can group these and add them to get 100, and 367 plus 100 we know is 467. Again, the flexibility with associative property. Here we do need to do things in different orders, so the commutative property is important. And 153 and 7 is 160. And then we need to add 19. So we ordered things differently, but we also associated them, grouped them together in different ways. So 179. And obviously when we can do that, when we can have that kind of flexibility with whole numbers, we can also have it with decimals. So here we can group 6.95 with 0.05 to get 7. And 7.89 plus 7 can be simplified fairly easy to 14.89. So this is just one way that you can see a little bit of flexibility happening when you're doing these additions, where there really is no need to add things in that order. What needs to happen is you need to be able to flexibly move things around to make it easier for you, but to still make sure that you come out with the same answer, that you're not changing the answer with the movement, with the change.